Have you ever wondered what happens when one of the ocean's giants, a massive whale, takes its last breath and dies? Does it simply disappear into the blue? Or does something far wilder occur? Picture a 50-ton blue whale, or a 60-foot sperm whale floating lifeless at the surface. Then slowly, silently, beginning its final journey, down, thousands of meters into the pitch-black abyss. For most of us, death is the end. In the ocean, a whale's death is the beginning of something insane, a brutal, beautiful explosion of life that can feed entire deep-sea communities for decades. Ecosystems form from scratch around a single carcass, drawing hundreds of species like the greatest buffet on Earth. Some whales sink immediately. Others bloat, float, and sink later. Why does this happen? And why does it matter? Today, we're diving into the wild science of whale falls, the insanely brutal way whales die and keep the ocean alive long after. If you're ready to see how death creates life in the darkest corners of the sea, stick around. And if these deep ocean mysteries hook you, hit like and subscribe, because we've got more coming. Before we dive into what happens after death, let's quickly cover why these ocean giants meet their end in the first place. Whales can die from natural causes like old age, disease, parasites, complications during birth, predation. A clear example of that can be seen in the case of orcas on calves, or smaller species, or stranding, which often leads to asphyxiation or exhaustion. But today, the leading threats are human-related. Entanglement in fishing gear, nets, ropes, crab pots is one of the top killers worldwide, causing drowning, severe injuries, infection, or slow starvation as whales can't feed or swim properly. Vessel strikes, ship collisions, deliver blunt trauma or propeller wounds, especially in busy shipping lanes. Other big factors include starvation from changing ocean conditions, like prey shortages due to climate change or overfishing. Then, pollution, which includes toxic chemicals, plastics causing blockages or illness, and noise pollution stressing them out. Even though the deaths of whales today can be brutally violent through suffocation, starvation, or human impact, these tragic endings do not bring only sorrow. In the depths of the ocean, a fallen whale becomes life itself, sustaining hidden ecosystems and carrying energy to the most remote corners of the sea. Let's continue our journey. First, let's understand how these giants move so effortlessly in water while alive. Whales are built for the deep. Some dive over 3,000 meters, holding their breath for hours. How do they control buoyancy to glide down without wasting energy or pop back up easily? Whales have lungs full of air at the surface, making them positively buoyant. They float naturally, but to dive deep, they need to overcome that lift. They do it with a combo of adaptations. Before a deep dive, many exhale partially or fully to reduce lung volume and buoyancy. Less air means less upward push. Their rib cages are super flexible, collapsing under pressure as they descend. Lungs compress dramatically, squeezing air into the trachea and preventing nitrogen buildup that could cause the bends. Oxygen is stored in blood and muscles. Huge amounts of myoglobin in muscles acts like a reserve tank. Blubber, which is a thick fat layer, helps with insulation and some buoyancy, while dense bones counter the flotation. Sperm whales even have a massive spermaceti organ in their head, a waxy oil that changes density with temperature and pressure, helping fine-tune buoyancy like a natural ballast tank. The result? Whales glide down efficiently, almost passively after the initial push, conserving energy for hunting squid or krill in the dark. Ascents are often passive too. Lungs re-expand, buoyancy returns. It's genius engineering. Alive, they're masters of vertical travel from sunlit surface to crushing depths. But when a whale dies, everything changes. No more active control. No more muscle contractions to adjust lungs or swim against currents. The body becomes passive, at the mercy of physics, temperature, and decomposition. Right after death, the The whale might float briefly thanks to any remaining trapped air in the lungs, the same air that made it positively buoyant at the surface while alive, or from blubber's natural lift. But without muscle contractions to hold or adjust lung volume, the lungs quickly deflate, flood with water, or lose air through relaxation. This removes the primary upward push that kept the living whale from sinking. Blubber still provides some ongoing buoyancy. Its thick fat layer is less dense than water and helps with insulation in life too. But once the air is gone and denser muscle and bone take over, the carcass often becomes negatively buoyant and starts to plummet. And this is where it gets really interesting. Many whales sink straight down after death, especially deep-diving species like sperm whales or individuals that die in cold, high-pressure waters. But why does this happen? Once a whale dies, active breathing stops immediately. The lungs collapse or begin to flood, and without constant movement to maintain air volume, buoyancy disappears fast. Living whales are close to neutrally buoyant, carefully balanced between fat, muscle, bone, and air. Remove the air, and that balance breaks. As the carcass descends, increasing pressure forces gases to dissolve into surrounding tissues rather than forming large bubbles. Without those expanding gas pockets, there's nothing to reverse the fall. The deeper it goes, the harder it becomes for the body to rise again. Besides that, the cause of death matters. Whales that die from starvation, old age, or injury often have reduced fat reserves and more waterlogged tissue, making them even denser. Less fat means less natural buoyancy, accelerating the descent. These whales, known as sinkers, reach the seafloor largely intact, and when they arrive, they deliver an extraordinary gift. A single adult blue whale carcass can equal thousands of years' worth of normal marine snow, the slow drizzle of dead plankton that usually feeds the deep sea. In a nutrient-starved environment, it's like a massive buffet meteor falling into a biological desert, an instant oasis where life erupts almost overnight. But that's not all. While some whales sink almost immediately, others float, at least for a while. The difference often comes down to temperature, body composition, and timing. In warmer surface waters, decomposition begins rapidly. Bacteria in the whale's gut break down soft tissues and release gases like methane, hydrogen sulfide, and carbon dioxide. These gases inflate the carcass, bloating it like a massive biological balloon and increasing its buoyancy. And sometimes, if the gas pressure builds up too much without escaping, especially in thick-skinned species like sperm whales, the bloated carcass can literally explode in a spectacular and messy burst of decomposition gases and tissue. This whale explosion phenomenon has made headlines worldwide, from beached carcasses popping on shores to ones bursting during transport. It's rare in the open ocean at depth, where high pressure keeps decomposition gases compressed, but on the surface or near land, it turns the floating phase into a literal bang before the remains finally sink. Besides these gases, blubber plays a major role too. Species with exceptionally thick fat layers, such as right whales and bowhead whales, naturally have more lift. This is why historic whalers referred to them as floaters. They were more likely to stay at the surface after death, making them easier to harvest. Fat is less dense than water, and when combined with trapped gases, it can keep a whale aloft far longer than expected, sometimes drifting for days or even weeks. During this time, it becomes a moving feast. Seabirds tear at the exposed flesh, sharks carve away chunks, and orcas may strip blubber in coordinated attacks. Each scavenger removes energy from the body, slowly changing its balance. But floating never lasts forever. As gases escape through natural ruptures, scavenger-inflicted wounds, or the collapse of internal cavities, buoyancy fades. Sunlight and warm water accelerate blubber breakdown, reducing lift even further. Eventually, the whale begins its final descent, often far from where it died, spreading nutrients across vast stretches of ocean as it sinks. This floating phase is temporary, but ecologically crucial. It ensures surface predators get their share before gravity takes over. Almost all whales end up on the seafloor eventually, but only after feeding life at the surface first, setting the stage for the deep-sea feast to come. When the carcass finally reaches the seafloor, often 1,000 to more than 4,000 meters down, it becomes a whale fall, one of the most dramatic events in the ocean. In the deep sea, where food is scarce and usually arrives only as thin drizzles of marine snow, this is an ecological jackpot. 30 to 100 tons of organic matter concentrated in a single place. Cold temperatures and crushing pressure slow decomposition dramatically. Unlike on land, there's no rapid decay. Instead, the carcass breaks down gradually, remaining intact far longer and sustaining life for years to decades, sometimes 50 to 100 years in extreme cases. What begins as a single dead animal transforms into a long-lasting biological engine. The whale fall creates a localized hotspot of biodiversity in an otherwise barren environment. Over 200 species can be supported across its lifespan, many of them found nowhere else on Earth. Scavengers, worms, crustaceans, and bacteria arrive in waves, each stage replacing the last as nutrients are consumed and transformed. This succession turns death into opportunity, fueling entire communities and reshaping the seafloor around it. In the deep ocean, few events deliver energy at this scale. A whale fall isn't just a carcass, it's a rare, powerful reset button for life in one of the most food-limited ecosystems on the planet. And here's the deal breaker. A whale fall doesn't just rot away, it transforms. When a whale carcass reaches the seafloor, it passes through 4 overlapping stages of ecological succession, much like a neighborhood that changes over time as new residents move in and old ones disappear. Each stage reshapes the community and extends the whale's impact far beyond its death. The first process is called mobile scavenger stage, which takes months and sometimes 1 to 2 years. Here, the first arrivals are the heavy hitters. Sleeper sharks, hagfish, often called slime eels, along with crabs and large deep-sea fish, detect the carcass from miles away. They swarm in, ripping into flesh and blubber in total darkness. Hagfish burrow directly into the body, consuming it from the inside out. In just months, massive amounts of soft tissue can be stripped away. It's fast, violent, and relentless, a feeding frenzy fueled by a food source the deep sea almost never sees. After that, we enter the enrichment opportunist stage, months to 5+ years. This process occurs once the large chunks are gone, smaller organisms take over. Polychaete worms, amphipods, snails, and crustaceans spread through the surrounding sediment, feeding on leftover organic material. The seafloor around the carcass becomes thick, nutrient-rich mud, capable of supporting dense populations. Life explodes outward, far beyond the bones themselves. Thirdly, we have sulfophilic, or the osteophagic stage. This is the longest and strangest phase. Lipids trapped inside the whale's bones break down through bacterial action, releasing hydrogen sulfide. Toxic to most animals, this chemical becomes fuel for chemosynthetic bacteria, similar to those found at hydrothermal vents. These microbes form mats that support clams, mussels, snails, and the stars of this stage. Osedax, the bone-eating zombie worm. Lacking mouths or guts, they use root-like structures to house bacteria that digest bone lipids directly. One skeleton can support over 30,000 organisms during this phase. Finally, we have the reef stage. This stage takes decades to centuries. You see, even after the nutrients are gone, the bones remain. They become hard surfaces in an otherwise soft sea floor, allowing sponges, corals, and suspension feeders to settle in. Long after the whale's energy is spent, its skeleton still shapes the ecosystem. The ecological impact is enormous. Whale falls boost deep-sea biodiversity, act as evolutionary hotspots, serve as stepping stones for vent and seep species, recycle nutrients, lock carbon into the seafloor, and support rare specialists found nowhere else on Earth. In a world starved of energy, one whale can sustain life for generations. So next time you hear that a whale died, remember, it's not the end. It's a beginning, a brutal, beautiful gift that keeps the deep ocean alive for generations. But one question lingers. With whale populations recovering, could more whale falls help fight climate change by sequestering carbon on the seafloor? Share your thoughts in the comments below. And remember, if this wild ride from surface death to seafloor life got you hooked, like and subscribe to join the next dive. Thanks for exploring with us. See you in the deep.